welcome to a Malman lesson. I wasn't able to find a video that went over parts of the graphs when we use Desmos, so we might be having a few of my videos in here. I'm not going to go through all the examples in the notes. We're only going to go over one. So I'm looking at quadratics, um, part of the graph story problems. This is right after the unit that we just did on solving to find all these, significant points like our, x-intercepts, y-intercepts, our vertex or turning points, which are also our max and mins. So we're going to now start using Desmos for this unit. This first one doesn't have Desmos. We're going to break down the graphs that we see. So we're just going to do this first one together. So looking at this graph, this is what we're going to get on Desmos. We're going to type in an equation. It's going to give us this graph. And if I click on these points, they will show up on Desmos for me. So that's kind of where this kind of starts. So this part right here on our next unit, we're just going to plug into Desmos. We're going to get it, and then we're going to analyze. All right, so let's start off. What form of equation are we looking at? The vertex, standard, or factored intercept form? So I would go up to my equation area. That's this part right here. And I look at this equation, I say, what kind is it? This is our factored intercept forms because I have the two parentheses. So that's a dead indication that we're looking at our factored forms. All right, the next question asks what each axis represents. So which axis is representing time and which one is representing the height? So here's this guy, he's throwing a ball from a window. Now remember, when we graph things, it's going to graph everything. We don't always want everything when we're analyzing, right? The ball's height, h, in meters from the ground is modeled by this equation. So just remember, this equation here, this is my y-axis, and this one right here, these little variables are the x-axis. So in this case, the h of t, that would be this right here, is my height. So I'm going to come here on my graph. I'm going to say, okay, well, this is my h of t. That way, no matter how they write it, this represents h of t. He represents height. And I go ahead and put in the meters. That way, every time I look at things that are my y values, that's what we're looking at. So if I come here, I'm going to highlight all my y values. Every single one of these, this 0, 14, 20.3, this 0, all of those represent the height of my of the ball. So wherever that ball is thrown, that represents the height. All right. So the next one, I'm going to kind of jump over. I'm going to change my pen to a blue. The other variable that I have is this t, and t, as I can see in my equation, represents the time, and it's measured in seconds. So here's the thing, what axis represents time? Well, that's this axis, that's our x-axis. And I'm going to come here to my x-axis, and I'm going to say, this represents t, he also is called time. And I'm going to put down his measurements, because every time they ask me a question regarding time, I need to make sure I put seconds, because that's the part that they need. All right, you always want to use your unit measurements. All right. So, and let's highlight those ones. Another color will highlight them. Let's go pink. So every time we use any of the pink values, we're going to say 7 seconds, 2.5 seconds, 0 seconds, -2 seconds, which we're going to talk about that in a second. It really doesn't exist. So when we get to those domain and ranges, anything past the 0 mark, we don't go back in time. So those will not actually exist. Right. So these first top the questions are very direct on just what is this, and then we'll go into solving like actual questions. So the next one, what one represents height? We already kind of talked about, that's our y-axis. So I come here and say the y-axis, and all of my y values are in height, and they're in meters. So whenever they ask me height, I'm going to say meters. What is the vertical intercept? That is where we start. So where did this ball start at? It started here. That's actually the top of the window. Remember, we can't go back here. So my y-intercept is at 0, 14, which means at 0 seconds, I'm 14 meters high. All right. What are the horizontal intercepts? Well, if they're asking just for the intercepts, we have two of them. We have this -2, 0, and we have this 7, 0. And just keep in mind, this is considered extraneous. It doesn't really exist in our story problem because we can't go back in time. All right, move these out of the way just a little bit. What's the maximum and minimum? These should all be really familiar. We've already kind of gone over them in the last unit. So it is a maximum. So I should circle that. It is a maximum, and it's 2.5 and 20.3. So that means in 2.5 seconds, the maximum height will be 20.3 meters high. So those are some basic questions. You're going to be asked more questions like this. And they're going to range based on what ones. They don't ask like 500 questions like this one. They usually ask like 1, 2, maybe 3. But I want to kind of get you familiar with the graphs and how to answer them. And then as we move on, you're going to see there are only about 3 questions. All right, when will the ball reach its maximum height? So I'd come over here and I'd say, okay, well, here's the maximum height, and it's asking when. That's a time question. So it's going to reach it in 2.5 seconds. So that's my answer, 2.5 seconds. And I do need to have seconds, otherwise you will get marked down, right? So make sure you have the unit, right? How high is the ball after 6 seconds? So if I came here, this one isn't quite on there quite as much. Sorry. So I got to move this again. Sorry about that. All right, so this is 7 seconds. So this is the 6-second mark. And it wants to know how high it is at 6 seconds. So here's my 6 seconds. Because remember, this is time, and I'm going to go up to my graph and figure out where does it cross, and it crosses right about here at this spot. So these are going by 1, so I'm going to go 1, 2, well, actually, I guess I should count here. 1, 2, 3, 4, 5, 6, 7. So that means it'll be about 7 meters high. Maybe 7.5 actually. Why don't we put that 0.5? All right, because it doesn't look like it lands perfectly at 7. So I'm going to change that to 7.5 or 7.5 or 7.6. Again, if we're not reaching exactly, and I didn't really see that, we want to kind of put that half. Right, at what time, so it's asking what x value, will the ball reach the height of 18 meters? So what was given to me this time were the 18. So up here, this is 14. So I can go up and go 15. It's hard to kind of see. 15, 16, 17, 18. This is where my 18 mark is. And I'm at 2 spots. I can go across and I can hit both of those on my graph. So those are my seconds. So I'm going to come down here and we're at 1 second. And this is landing right on the intersections. And then the next one lands right about here. So that's 6, 5, 4. And I'm abbreviating seconds where I can count 1, 2, 3, 4. So those are the ones that it meets. All right, how many seconds until it hits the ground? Well, remember, we're not really caring about this side. This side really doesn't exist to me. All right, this is where it starts. We start at 0 seconds and then the time moves forward. We don't ever go back in time. So when it hits the ground is right here. That's when the height is at 0, and that's at 7 seconds. So I'm going to go 7 seconds. The ball will finally hit the ground. How high was the window that the ball was thrown out of? That's my initial starting spot. So again, I'd come here and say, well, it initially was at 14 meters, and then it kind of goes up, and then the ball starts to head down. So it was thrown from a window that must have been 14 meters high. And then what's the practical range? So our range are our y values. Change this. So I'm going to go, there are y values. Now I'm not going to put y here because they don't have y. I'm going to use that h of t. The height begins, or the lowest that we go is at 0 when it hits the ground. And I put my wonderful inequality signs. Remember, I'm not going to put y, I'm going to put his function notation version of y. And then the highest it goes is all the way up here to 20.3. So it does not go past 20.3. That's why it's a maximum, so that's the height it goes. Domain, when we're building domain, keep in mind that's our time. We cannot go past 0. So even though our graph shows it, Desmond's going to show us this, we ignore it the only parts that we care about are from 0 all the way over to 7. So that will be our domain. And his variable is t, so we're going to switch the x to a t, and we're going to say 7. So again, this set of notes is kind of asking you a bunch of different questions that they can ask you as a story problem when we get to plugging them into Desmos, and you're just practicing. I'm going to give you the graph today, and then tomorrow and the next few days you are going to have to graph them on Desmos, but then it's the exact same stuff as this. So the only new thing would be you to graph on Desmos. All right, I hope that helps, and I will see you in class.